Every day, more than 4 billion objects from space, known as meteoroids, are pulled into Earth's gravitational field. This term refers to bodies larger than interplanetary dust but smaller than asteroids. Most of them are tiny rocky fragments that burn up rapidly while entering Earth's atmosphere. Only a very small number manage to survive this fiery barrier. When meteoroids actually reach the ground, they are called meteorites. In general, they are not considered a serious threat, though once in a while they can alarm people nearby, like the famous Chelyabinsk event in Russia in 2013. But what would happen if a meteorite were moving at the speed of light? In reality, objects with mass cannot truly reach light speed, but for this scenario, we don't need to reach it exactly. Simply getting extremely close to that speed would already create a disaster powerful enough to shock the entire solar system. But let's approach the idea step by step. Imagine a perfectly round diamond sphere with a diameter of 30 meters. Now picture launching it toward Earth at a speed of 3,000 kilometers per second. At such incredible speeds, the air in Earth's atmosphere would actually begin undergoing nuclear fusion. The intense plasma heating produced might even destroy the diamond sphere before it reaches the surface. But let's assume Earth isn't that lucky. The sphere stays intact long enough and eventually crashes into the planet. The impact would release energy thousands of times greater than the strongest nuclear weapons ever detonated. Everything in the surrounding region would be instantly wiped out. Still, that's not very exciting. After all, that's only about 1% of the speed of light. The crater would be enormous, and the heat would blast rock outward at nearly 0.99 times the speed of light. At this point, relativistic physics begins to play a role. The bonds holding the diamond sphere together would completely fail. Instead of a solid object, the meteorite would become a swarm of individual carbon atoms, moving so fast that Lorentz contraction compresses the sphere into a flattened pancake. Of course, we wouldn't actually be able to see this effect with our eyes. Each carbon atom would carry around 70 billion electron volts of energy. They would be moving so fast that instead of colliding with their molecules, they simply pass straight through them. Asterisk air molecules would penetrate about 3 meters into the sphere before getting trapped inside. The object would rapidly expand and reach Earth containing even more matter than when it began falling. The moment it hits the ground, it completely disintegrates, tearing through Earth and carving out a massive cavity, forming a cone-shaped tunnel deep into the lithosphere. The impact would punch through Earth's crust and create a crater so huge that molten mantle would be visible. The energy released would be roughly 50 times greater than the Chelyabinsk asteroid that wiped out the dinosaurs in Mexico. That would be enough to trigger a global mass extinction, possibly even ending all life on the planet. Would you want to witness something like that? Personally, I would prefer not to, but that's still not impressive enough. Let's add a few more nines to the speed. Now the sphere is traveling at 99.9999999% of the speed of light. Each carbon atom now carries around 25 trillion electron volts of energy. That's comparable to particles accelerated inside the Large Hadron Collider in Switzerland. At that speed, the object would strike Earth with kinetic energy similar to the Moon moving in its orbit. That level of energy would tear a gigantic hole deep into Earth's mantle. The planet's surface would be so violently disrupted that it would begin to melt. At this point, the chances of life surviving on Earth would be extremely small, but even that isn't the limit. Let's push the speed even further. We now reach the velocity of the fastest massive particle ever recorded by humans, the famous Oh My God particle. This extraordinary particle was actually detected in 1991 above Utah. It was a proton from outer space traveling almost exactly at the speed of light. Its speed was about 99%, followed by 21 nines. The particle cascade created during its collision with the atmosphere has never been replicated, even in the Large Hadron Collider. Similar events are detected several times every year, yet scientists still don't fully understand how such particles are produced. They seem to originate from the direction of distant galactic explosions. But what could accelerate them so dramatically, and why they don't slow down on the journey here, remains a mystery. For now, let's borrow that same speed for our diamond sphere. At such extreme velocity, no modern computer can accurately simulate the event, so we can only estimate what might happen. The diamond sphere would pass through the atmosphere almost without interacting with it. Then it would plunge straight into Earth's crust. A massive cloud of expanding plasma and radiation would erupt from the entry point. Energy waves would surge through the entire body of the planet. Just 40 milliseconds later, the opposite side of Earth would begin expanding outward as a glowing cloud. The meteorite and the particle cascade produced by the impact would continue spreading through the planet. The entire Earth would begin glowing brighter than the Sun due to extreme overheating. The impact could even push Earth into a completely different orbit. Though by then, it wouldn't matter anymore. The energy released would be 10,000 times greater than Earth's gravitational binding energy. As a result, the planet would explode into a rapidly expanding cloud of plasma. Jets of extremely energetic material would blast outward into space from the direction of impact. The Sun itself would be briefly surrounded by waves of dust from the explosion. Nearby planets would be struck by intense high-energy plasma shockwaves. Now that's what you call fireworks. Since you made it to the end, you probably enjoyed the video. Don't forget to hit the like button and subscribe to the channel. More exciting videos are coming soon, so stay tuned. See you next time.